Good morning, students. So, today we are going to discuss the another method for conversion of units into other units. As in the previous video, we had discussed about the method for conversion of units into other units. If the question is given in one system of unit and we have to convert it into other system of unit, then directly in the given formula we are putting the values of the unit and then we are going to convert it into other new system of unit. Now, as in the previous video also we had discussed that there is some another method, so today we will discussing that method. What is the method? So as you know that, as we know that numerical value into unit is equal to constant. So n1 into u1 is equal to n2 into u2, and from here we can write it n2 is equal to n1 n1 u1 upon u2. Suppose this is equation number 1, because we are knowing that numerical value into unit is equal to constant. So from there we can write as, suppose this is the numerical value for first system of unit, this is unit for the first system of unit, this is numerical value for second system of unit, and this is the unit for second system of unit. So we had calculated the numerical value of second system of unit in the terms of first system of unit and unit of second system. So u1 can be written as m1 power a, l1 power b, and t1 power c. This is the given system of unit, and the next system of unit u2 is equal to m2 a, l2 b, and t2 c. This is the second system of unit. Now from equation 1 we can write, that is n2 is equal to n1 u1 upon u2. From this equation we can write n2 is equal to n1 u1 m1 power a, l1 power b, and t1 power c upon m2 power a, l2 power b, and t2 power c. And from here we can write it as n1 m1 upon m2 raised power a, l1 upon l2 raised power b, and t1 upon t2 raised power c. So n2 can be written as n1 m1 m2 a, l1 l2 b, and t1 upon t2 c. t1 upon t2 c. Clear? So we had expressed one system of unit into other system of unit. By this method we are solving two numericals. Two numericals we are solving by the help of this method. Then we will consider the principle of homogeneity, by which we can check the consistency of dimensional formula, correctness of dimensional formula, or consistency of dimensional formula. Okay. Look at it. By this method we are doing It is for the sake of the thing that both the methods become clear to you. Example 1, write it down. A calorie is a calorie is a unit of heat or energy, and it is equivalent about 4.2 joule, where 1 joule is equal to 1 kg meter square per second square. Suppose we employ a system of units in which unit of mass equals alpha kg, unit of length is beta meter, unit of time is gamma second, so that calorie has a magnitude 4.2 alpha inverse beta minus 2 gamma square in terms of new unit of new unit. Okay, this is the question, and we will solve this question by whatever the method we had studied right now. Look at the question. First of all, try to understand the question. A calorie is a unit of heat or energy, and it is equivalent to 4.2 joule. 1 calorie is equal to 4.2 joule, and 1 joule is equal to 1 kg meter square per second square. We have to imply a system of unit in which unit of mass is alpha kg. This is the new system of unit. This is the given system of unit. 1 joule is equal to 1 kg meter square per second square, and calorie is equal to 4.2 joule, in which unit of mass alpha kg, unit of length beta meter, unit of time gauss. So that calorie has magnitude 4.2 alpha inverse beta minus 2 gamma square in terms of new unit. So we have to show that in terms of new unit, calorie can be represented like this. In terms of new unit, calorie can be represented like this. So okay, let us solve this numerical by whatever the approach we had studied. Look at here. Dimensional formula for energy. Dimensional formula for energy, and it is equal to m L square T minus 2. All of you are knowing this. Okay. Dimensional formula for energy is m L square T minus 2. M1 L1, T1 and M2, L2, T2 are units of mass these are the units of mass, length and time in two given system of unit. Two given system of mass, length and time in two given system of units. M1 is equal to 1 kg, L1 is equal to 1 meter and T1 is equal to 1 second. M2 is equal to alpha kg, L2 is equal to beta meter and T2 is equal to gamma second. Now this is the given system, or this is the new system. Now using our formula, N1U1 is equal to N2U, and from here N2 is equal to N1 U1 upon U2. Clear? So it is given in the question that N1 is equal to 4.2, U1 is equal to M1 L1 square T1 minus 2, and U2 is equal to M2 L2 square T2 minus 2. Then 4.2, it is equal to M1 upon M2 L1 upon L2 square T1 upon T2 minus 2. If M1 is 1, then M2 is equal to alpha. So 4.2, that is 1 alpha 1 beta square and 1 gamma minus 2. And from here we can write it N2 is equal to 4.2 alpha inverse beta minus 2 gamma square. 4.2 to gamma square, and this is the new unit. This is new. N2 is equal to 4.2 alpha inverse, and we can say that 1 calorie is equal to 4.2 alpha minus 1 beta minus 2 and gamma square. 1 calorie is equal to 4. Alpha minus 1 beta minus 2 and gamma square. This is in terms of new unit. This is in terms of new unit. Then write the next question. When 1 meter, 1 kg and 1 minute. Example 2. When 1 kg, 1 meter, 1 kg and 1 minute are taken as the fundamental units of the magnitude of force is 36 units. What will be the value of this force in CGS system? What will be the value of this force in CGS system? Clear? CGS system means in the given system, that is a SI system, and in this system, in the given system, length is measured as 1 meter, mass is measured as 1 kg, and time is measured in 1 minute, are taken as fundamental units, and the numerical value in the first unit is 36, that is n1 is equal to 36. It is given in the question, n1 is equal to 36. What will be the value of the force in CGS system of unit? CGS system of unit, when length is taken as 1 centimeter, mass is taken as 1 gram, and time is taken as 1 second. So let us solve this question. Dimensional formula for force. Dimensional formula for force, and it is equal to mLT minus 2. Now, in given system, whatever the system given in the question, n1 is equal to 36, m1 is equal to 1 kg, L1 is equal to 1 meter, and T1 is equal to 1 minute. It is given. And in new system of unit, in new system, n2 is equal to what we have to find? m1 is equal to 1 gram, L1 is equal to 1 centimeter, and T1 is equal to 1 second. T1 is equal to 1 second. So n2 is equal to n1 m1 upon m2 a L1 upon L2 b and T1 upon T2, that is equal to C. Now m1 m2 L1 L2 and T1 T2. Now putting the values, that is 36, it is n1 value given 36, 1 kg upon 1 gram power A, 1 meter upon 1 centimeter power B, and 1 minute upon 1 second power C. Now look at here, that is equal to 36 1000 gram, 1 gram power 8, 100 1 centimeter, and 60 second upon power C. Clear? So A, B and C, we can compare A, B and C as the value MLT minus 2. As in the starting we are taken as force is equal to force F is equal to MLT minus 2. Clear? So M is equal, A is equal to 1, B is equal to 1 and C is equal to minus 2. 1, 1 and C is equal to minus 2. We had discussed in the dimension for the force, and so it will become 36 into 1000 into 100 into 60 minus 2. And from here we can write it as N2 is equal to 36 into 10 to the power 5 into 1 upon 36 into 10 to 3600. So it will be like that. So 36 to 36 cancel out, 10 to the power, so N2 is equal to 10 to the power 3, done. In CGS system, N2 is equal to 10 to the power 3, 9 in CGS system. Now we will check the consistency of the dimensional formula. The fourth application for dimensional analysis, the fourth application is the consistency of dimensional formula, and for the consistency of dimensional formula we have to check the dimensionally. If the dimensionally correct, the given physical relationship is dimensionally correct or incorrect. On the basis of this dimensional consistency of the given physical quantity, and it is based on the principle of homogeneity. To check the dimensional consistency of a given physical relation, in this case, by the help of principle of homogeneity, we will check the dimensional correctness. Okay, so this will be discussed in tomorrow's video. Thank you for today. That's all, students. Thank you.